about the microcontrollers that are used in a KNX device. So the KNX device is that what I will explain here. So specifically the aspects hardware and software. So in the context of microcontrollers, of course. Then I will give an overview of the components, and then I specifically will give some more details on BCU1 and on the the higher versions of that. So starting from BCU2 onwards, and higher as said. So okay, here we start with. Sorry for that. I have to click that away. KNX device hardware. So first of all, a few definitions. So a KNX device is actually either a combination of an application module and a so-called BAU, a bus access unit, or it is a combination of an application module and a bus coupling unit, where then a bus coupling unit is as such a combination of a PEI, physical external interface, a microcontroller, and a UART / ASIC combination. An BAU, so a bus access unit, is then the same thing as a BCU, but as you can see, without a PEI. So indeed only a microcontroller and a UART ASIC combination. So here we see the abbreviations, indeed, as I have been saying, as I have been using them. An application, AM is an application module. So examples are a 4-volt push button, a 2-volt dimmer, etc. And BAU and BCU, I have been using the abbreviations already. So bus access unit indeed and bus coupling unit respectively. PEI is a physical external interface, which is actually a standardized interface for application modules. So in order to, let's say, connect an application module to or on a KNX device, we can either use let's say a proprietary interface or a standardized interface. If it's a standardized interface, it needs to be via the so-called PEI. A microcontroller as such is actually a microprocessor with some peripherals. Peripherals can be or typically are memory, timers, so that means the specific hardware, of course, for memory, for timers, input-output ports, and ADC. Okay, what is meant by memory? Well, indeed, it's either ROM, read-only memory, which is typically used in order to store example-given mask information. Another type of memory is random access memory, so RAM. And this is typically used for, so in the context of KNX, of course, for group object values. And there's also EEPROM. Memory can, for newer generations, mean that flash is used. So it is actually the case. So for newer generations, flash is used, which is also a type of EEPROM. However, it is cheaper and faster. So where the classic EEPROM, if I can use that word, is actually indeed limited. So it is back then was really expensive, and also it had the disadvantage that you could only write this for more or less 10,000 times, and then they were damaged. I/O ports. Well, that can be digital ports, analog ports, the parallel port, a serial port, and also it are the I/O ports that are used in order to set up a PEI. So again, the standardized interface for a KNX device. ADC, I've been using that abbreviation here. Well, here it is. Here you can see what it actually stands for. So it's the analog digital converter. So that is to indeed convert analog signals into digital information. And is example given used in order to measure temperature, but certainly in the context of a KNX device for bus voltage, and also to find out the PEI type, because every application module, well, first statement is there are the number of application modules is limited, and each type has then also a so-called PEI type, which is actually how to say, realized by means of a resistor. So actually, it's the ADC of the microcontroller that is used in order to find out which PEI type is on board or is connected, and that of course then indicates which application module type has been used. UART. So what is a UART? A UART is actually an universal asynchronous receiver transmitter. An ASIC is an application specific integrated circuit, and they respectively actually represent the link layer or data link layer and the physical layer of the KNX communication stack. A BIM. So BIM is also a specific device type, if you want. We will see that in the next slide as well, or in one of the next coming slides. But I can already tell you now, this is a bus interface module, which is actually the combination of a PEI, a microcontroller, and a UART. So what is missing here is indeed the ASIC. So that is actually not on board here, or it's actually, to be more precise here, the ASIC is actually integrated in the UART. Okay, KNX device software. Well, first of all, there is the application program, which is indeed, it's APE, it's the application program, and is actually a combination of, or there are actually two parts here. There is a loop with check routines and some additional routines. So that means there is a constant, so this application program is in a constant loop, and within that loop there are check routines that are applied, and besides the check routines in the loop, there are also some additional routines. So what are the loop check routines? Well, that is the communication stack as such, so things that happen in the physical layer that need to be checked, or some events that occur because within a physical layer, data link layer, transport layer, and application layer, that is checked in the loop check routine, so that's part of that. The user application, so that is to apply bus service or user actions and to provide the corresponding data. So that means, what this means concretely, example given, if the product is an application, is a push button, then this means that the events, if let's say the user would manipulate one of the rockers, well, then this is then, how to say, checked by the loop check routine, and that is what is meant by this user application. Or the other way around, if it's a binary actuator, then this means that if, an example given, a relay needs to be opened or closed, well, then this is also the user application part. And there are some general loop check routines also. That is to check the application module PEI type, as just explained before with the ADC, because this is important. Because if there is, let's say, a mismatch, so if the application module is, example given, so physically on the device, if the application module is a push button, well, then it is of course not okay when the application program would be for a push button. So a push button does indeed cannot be used for an actuator, for a binary output, or the other way around. Of course, it doesn't work either. So therefore, this needs to be checked constantly in order to protect the KNX device. What is also constantly checked is the EEPROM checksum, because if something would be wrong with that EEPROM checksum, that could be an indication that there is some EMC interference, example given. So therefore this needs to be checked as well. And there are also some possible runtime errors that could occur. In that case, well, those runtime errors are in most of the cases just solved by reloading the application program. What are then the additional routines? So again, these are the routines that are checked constantly. They're just going in a loop all the time. So when the last check routine is done, it will just start again with the first one, and so on and so on. Additionally is when there is an initialization routine, a reset routine, bus voltage drop routine, and also timer interrupt is also a specific routine. So in case of initialization, that means when the device is powered up, well, typically what happens then is that the group object values which were stored are going to be put in RAM. That's during initialization. Reset could also require some specific routine to be handled. That needs to be handled indeed. And the bus voltage drop routine is also particular because in most of the cases it means there is indeed an interrupt, so that the device will then automatically in these routines, example given, store the group object values which are in RAM. Well, those values will be stored into EEPROM in order not to forget, in order not to lose information. Well, okay, that's what I want to say about the KNX device software. Then here an overview of the different components. So I have here set up on the left side, so I have set up a table on the left side. The left column is the medium that is used and the mask version. So we see twisted pair, power line, twisted pair, twisted pair, twisted pair, and also here twisted pair, radio frequency and IP. So in the and then also of course the KNX profile that is actually used, and the different products, so the product names that were used, that are used, the physical layer, so specifically which components are used, which microcontroller, and whether the product or the profile, if you want, or the component serves the serial number feature, yes or no. So the overview is, let's start on the top. So the first KNX devices that were brought to the market had the medium type twisted pair and had the mask version 0, 1, 2 were System 1 devices, and the products were called BCU1 and BIM M111, and the physical layer was actually implemented by means of a chip called, or a product called ASIC 1065. The microcontroller that was used in these System 1 devices, in the BCU1 devices, were the Motorola microcontrollers, so 68HC05B6. This product didn't support serial numbers. So there was no serial number for a BCU1. That's actually what it means. An alternative came a few years later that was, so it's actually the same, however for another medium. It's called Powerline. So that we can see here in the mask version also as such. And there were also System 1 devices, were also called BCU1, but of course Powerline BCU1 or the so-called power line interface module, the PIM. The physical layer was also a specific component called Busch-Jaeger Electronics ASIC, and there was also nearly the same microcontroller that was used, so it was from the same family, but a bit different though. Also here no serial number. Then next generation were the System 2 devices, so still twisted pair, and we can see here indeed a higher, another mask version. And the products were called respectively BCU2 and BIM M113. So also the ASIC was upgraded, and also we can see that a different Motorola microcontroller has been used. Same family though, but a bit different. Here serial numbers were indeed supported. And what we also can see is here, so I have put here a strike-through effect in the text. That means, how do we have to interpret this? It means that this Motorola, this specific type, is not available anymore. You cannot buy it anymore. So the remarkable thing here is that although the System 1 devices were earlier on the market, so I'm talking here, speaking about 92 if I'm not mistaken, well, despite that fact they are still on the market, they still are available. Whereas for this newer type, these microcontrollers are not available anymore. Okay. Then later on, still System 2, but with an upgrade. So now it's another mask version indeed. So it went from 21 till for 0021 from 0025. Here the product is called an BIM M113, which is the replacement of this product here. So there was no replacement for BCU2, but it was specifically for the BIM. UART has then been used as for the implementation of the physical layer, and another microcontroller as well. It's from manufacturer NEC, and the type is 78K0 or KE2 /KE2. Also here serial numbers are supported. Later, there were the System 7 device was brought to the market. This product is called BIM M112 and is using actually the same ASIC as example given the BCU2. However, with a different another microcontroller indeed from Motorola again, which is also not available anymore on the market. Serial numbers are supported here. And then let's say the latest generation of devices, so they all support twisted pair, radio frequency and IP, so not power line. And these devices or these components, they can be used either, or can be brought to the market either as a System 2, a System 7, or a System B component, or System B or device. The products here used, so the specific hardware, well, that is actually what is a bit different. It means this is now open and is based on so-called certified stacks or modules. Because there are now KNX members so plural, that can offer these certified stacks or modules. The physical layer is either based on a UART or discrete components, or discrete components. And examples of microcontrollers, because this is also open, so it depends a little bit on the provider also, either example given RL78 from Renesas or the Texas Instruments MSP430. Also here serial numbers are supported. Okay, now let's have a look at some BCU1 specific memory locations. This in order to, well, make it better understandable for you what is the specific use case. Also in regards of the preparation of the tutor course, of course. So the address 104 hexadecimal is very special in that sense, or very important, that it is actually it represents the identifier of the manufacturer. So who is the manufacturer of the KNX device? So example given, why is this important? If this doesn't match with the application program, because also the application program needs to have an identifier of the manufacturer. So here is again a way to protect the product. So if already the product, the hardware so to say, doesn't match with the software, then ETS will refuse to load that software because something could go wrong. So it's the same principle as for the application module. So if the application module, let's say the type of the application module doesn't correspond with the type that is expected according to the application program, then also inside that KNX device, the application program will not be, it might be loaded, so you can load it with ETS, but it will not be started. So it's actually nearly the same principle. Just one remark here about the manufacturer ID. Indeed, this is only one. It's only 1 byte or 1 octet, better said. So it's only 8 bits. So maximum we can only encode 255 different manufacturers if we don't use 0, of course. Although we have more than 400 members, so how do we? So why is that? Well, that's because of BCU, because it's BCU1. So back then we only we didn't have 400 members. That's the first thing. And second, well, indeed, not all members are interested in BCU1 devices, so they will not. They probably will. They rather bring, of course, newer generations on the market. Okay, then next field or next important information that can be found in a BCU1 is actually a collection of free octets. So on the addresses 105, 106, and 107, and that is actually an identifier of the application program. So that is those 3 bytes together, those 3 octets together, make the application program unique, right? Because they contain the device type and the application version. Then 10D contains the runtime errors. So the runtime errors can be looked up in other documentation, so that you just know for now, okay, we can find it indeed on this address. 10E is then the hop count, which is also known as the routing counter, so the hop count value. Well, here it needs to be put to 6, otherwise, well, maximum 6, otherwise such a device cannot pass the certification. In 10F, there the number of data link layer repetitions are put, so this is also certification relevant, needs to be 3 maximum. 116 is then actually the start of the so-called address table, and it starts with the number of addresses that can be found in that address table. The first address in the address table is always the individual address, so it takes indeed 2 octets, so 117 and 118. And then the next, so from 119 onwards, we will always use 2 octets indeed in order to put the group addresses that are used for this specific device. So example given, if in 116 there would be put the value would be put the value put there would be 3, example given, well, that means that there is actually 2 group addresses, because one address is already used for the individual address, and the 2 additional addresses or two additional groups of 2 octets, of course, are then used for the group addresses. So 3 means 1 plus 2. 4 means 1 plus 3, and so on. Okay, then the additional features that were added to KNX devices from BCU2 onwards, or System 2 devices. First of all, there's the BCU key. So that is indeed let's say a setting within a ETS project, and that is indeed in order to control the memory access of those devices, or to protect that memory, so that devices cannot be programmed without this password actually. So this has a length of 4 bytes. That means, well, in total 16 keys can be attributed per bus device in 4 access levels actually. And again, it's just to protect the device against, let's say, programming from another, maybe from another ETS. So if you protect it with your ETS, with your project, with this BCU key, then someone else cannot do that unless, of course, that person knows the BCU key, of course. But as such, it is indeed a protection for overwriting memory. As said, indeed, from BCU2 onwards, there were serial numbers, which is interesting as such, because it uniquely identifies the devices on the bus. Because with an individual address, this is not necessarily the case, because nothing prevents you from giving, let's say, 10 devices in the installation the exact same individual address. As such, it's not good practice, but you can do so. So therefore, there's also the serial number, but again, only from BCU2 onwards. By the way, this is also interesting to know that, well, that there is an app that can program, let's say, or that can put the BCU2 device, or higher of course, into programming mode without pushing the programming button. So that could be done via the serial number. More information is of course to be found on the KNX online shop. Then BCU2 devices and higher also support KNX interface objects and properties. So objects, so the concept of properties, objects and properties. That means this is a concept that has actually a memory or platform independent data structure, so which is used typically for parameters and for addresses. All these objects, these interface objects and their properties can be read or written by yet another app called ETS Device Editor. So written with the editor, reading and writing by the editor, but there's also ETS Device Reader. Well, then it's only for reading. Also supported from BCU2 onwards is a PEI program, so a physical external interface program. But this is only from System 7 and System B, only for System 7 and System B. What is this PEI program? Well, this is indeed an extra software routine specifically for the PEI, and this is then existing besides the, if I can use that word here, the regular application program. So this is typically used in order to interface the KNX device with another microcontroller. That is a typical use case. For the certification, I can say that the PEI program is not required. So the BCU2 device or higher doesn't need to have the PEI program. So that's not not strictly required. The application program, the regular application program as such, however, is required. And then I just want to explain you, and on the one last slide, let's say because BCU2 does support these objects, these interfaces and properties, I just want to explain you indeed the difference between memory and properties. So what we see indeed, the concept of accessing memory, so to access data via memory locations, is that of course when you want to do it in that way, or when you want to use services that rely on this concept, you need to know the exact memory location and the length in advance. Before you're going to use such a service, you need to know it. So typical service that is defined is read memory. So again, if it would be example given, the address location 22E, and you want to read out 100 octets, well, then you have to specify it as such, right? However, if so this would be the case typically for BCU1. You can also do it in the same way for BCU2 and higher, of course. But the nice thing about BCU2 and the higher, let's say, mask versions, is that they also offer actually access to the same data, but then via properties. Here, as such, you only need to know the property identifier. So here we use a separate, it's a separate, how to say, it's a different, a little bit different concept, because what is used additionally here is a so-called mapping table. So a mapping table between the property identifier and the memory location, so the combination of memory location and length. And the service that is using this concept is, example given, the read property service. It takes only one parameter. So that means indeed, instead of read memory, so like this, we directly read into RAM example given, we need to know which memory location and how long, how many octets we want to read. If we do it via a property, well, then the service read property will use the identifier of the property in order to find out where this is located in memory and how long this memory block is. So that all happens actually internally inside the device, so we don't need to know it by heart. That means indeed the service will then respond in this way, so it will look up the memory location and indeed the length. And before I conclude the webinar, I want to still present a few extra slides, and while doing that I want to thank you for being here. I want to thank you for your attention, for considering KNX, and maybe we see one another in one of my future webinars. So thanks again, and goodbye.